13 is going to be a problem where you have to solve a log equation. So you see a minus or a plus there, and you're going to use log rules to combine this together first. So we're going to be going the opposite way than we did for the previous problem. The other one was expansion, so now this one you're putting them together into one. So we're going to use log 3 is going to be the main one. So whatever base you have for these two will be the same base down there for that one. And then the subtraction turns into division. So you're going to have x minus 5 on top and 2x plus 3 you're going to have down below. Now that's going to equal 0 on that side. What you want to do next is change this from log form into exponential. So we combine it together into a single log first. Now we change from log form to exponential. You do that by taking the base 3, we're going to raise it to the number after the equal sign, 3 to the 0, and it's going to equal everything else we have here. So again, subtraction turns into division. If this is a plus, then I would have been multiplying those two together. It's a different log rule. Okay, so this is division. Base, raise the number after the equal sign, equals all this. That's changing it from log form into exponential. Now, anything raised to the 0 power is 1. So whatever this ends up being, if it was 3 squared, I'd have 9, for instance. But anything raised to 0 would be a 1. So I have 1 equals x minus 5 over 2x plus 3. I can actually write this as 1 over 1. And then what I'll do is I'm going to cross multiply. So I'm going to multiply this diagonal together and I get 2x plus 3. And if I multiply this diagonal together, I get x minus 5. You could have also multiplied both sides of the equation by 2x plus 3 to cancel out the fraction on this side. You would have gotten exactly the same answer here. Let's solve for x. So subtract the x's and I get x plus 3 equals negative 5. Subtract the 3's. I get x is equal to negative 8. Is this the final answer? Wait, you have to make sure the answer that you get, you need to plug it back into the original equation. If you plug this back in and you get a negative number as a result inside one of the logs, then the answer is not in the domain and we can't include that answer. If I take negative 8, plug it into here, I get negative 8 minus negative 5. That's going to result in negative 8 inside, which I know I can't do. Log of a negative number is not in domain, so therefore this answer we can't include. Now even if I put negative 8 into this one, I still would have gotten a negative answer. So if you get a negative number as a result inside the log, we can't include that. Therefore, what you'll put here for your answer is going to be no solution. Is a division problem always going to end up in no solution? No. Depends on what you get for the answer. If this would have resulted in like a positive 8, then I would have been fine. I would have put that down as my answer. But because I got negative and I checked it and it didn't work, then I get no solution. So you got to check your answer. It's not always true that every single time you'll get no solution. Just take your answer and plug it back into what's inside the parentheses inside the log.